Welcome to the IoT Unicorn Podcast. This is Pete Bernard from Microsoft. We have a very special guest today. We're going to be talking about long-term technology trends in the IoT space. So let's get started. We have an interesting conversation today with Jeff Torrance, who's the VP of IoT at Qualcomm. And I think a lot of folks probably know Qualcomm from the silicon that they're providing to kind of virtually every phone that's out there today. Also, they have this really interesting IoT business, and we're going to talk to Jeff about 5G and IoT and when that's happening and what's going to be happening when that hits the market. So we'll talk a little bit about that. We're going to talk about spectrum policy and private wireless. We'll talk about honeybees. We'll talk about low latency and some really interesting topics. So get comfortable and enjoy this conversation with Jeff Torrance. So are you dialing in from San Jose, by the way? Are you in the Bay Area?
Yeah, I'm in San Jose.
Fantastic. And so maybe give us a little bit of a background on how did you get to Qualcomm? How did you get to San Jose at Qualcomm doing what you're doing? It's kind of I'd like to hear a little bit more about your personal journey.
Okay, well, the simple answer is Qualcomm acquired a company called CSR in 2015. And I had a role at CSR and came into the company. The journey's a bit more interesting, really. You know, historically, I'd worked in mobile. I'd been heavily involved in the 3G standard back in the late 90s, and we'd formed a startup company that had been acquired by CSR. That company was called Ubernetics. And then when I joined CSR, we were very focused on building Bluetooth technology that was going into cell phones.
Right.
And there were like two vectors which were making that more challenging. You know, one was the big mobile phone technology companies like Qualcomm were providing more of the solution going into the cell phone. So the smaller companies like CSR had less space to differentiate. And on the other side of the equation was the opportunity to deploy the technology CSR had in adjacent spaces was growing very rapidly. So around 2012, I was central to a group of people within CSR that really pivoted that company from being a mobile business to being an Internet of Things business. And we pursued that strategy for 2 or 3 years, and then Qualcomm acquired us. I see. So at the point Qualcomm acquired, we already had some experience in building an Internet of Things business. So Qualcomm were, kind enough to offer me a position in that space, in the Internet of Things space, when the acquisition closed. And so for the last 5 years, I've been working in the Internet of Things business unit at Qualcomm.
Super. And how long have you been in the Bay Area?
Oh, I came to the Bay Area in 2009. CSR merged with a company called Surf. At the time, I was leading corporate development and strategy, so I was on the sharp end of that transaction. And in the summer of 2009, the CEO said, "That's a great deal. Would you mind spending the summer in San Jose to help with the integration?" And here we are, 10 plus years later. It's been a very long summer.
I see. Yes, exactly. And where did you move from?
From Cambridge in the UK.
Oh, okay. That is a big transition. I lived in Palo Alto for a year when I was in the Bay Area. It was pretty cool. I moved from Boston to Palo Alto. So, it's quite a transition living out there, and it's a pretty cool space to be in. So you're at Qualcomm now. You've been there for a little while, and Qualcomm is kind of gearing up in the IoT space and building a business there. And obviously, maybe not obviously, but from my perspective, Qualcomm is kind of the face of 5G for a lot of folks. I think that the vision that Qualcomm has been articulating around 5G has been pretty compelling for a number of years now. And you can walk into pretty much any store and pay a lot of money for a 5G phone, which is pretty cool. We can talk about that. But I think what's more interesting is when 5G starts to sort of get beyond phones, especially in the kind of commercial space, in the IoT space. And I know you've been thinking about that as well. I mean, when do you expect to see that happen beyond the phone space?
Okay, we can talk about that. I think it's probably worth setting a little bit of context first, Pete.
Sure.
So Qualcomm's investing, $4+ billion a year in research and development, building chips for cell phones. Mm-hmm. And an important aspect of that is the transition from 2G to 3G, 3G to 4G, 4G to 5G, and progression of radio technology. But there are two other important pillars which Qualcomm's technology is built upon, and the first is compute. So we are building the smartphone compute, whether that's graphics synthesis, whether that's computer vision, camera, running the operating system on the cell phone. That whole compute processor is an important leg for our technology. And then the third important leg is security. So we have to, you imagine that the number of devices Qualcomm in presents a really large cross-section for bad actors. And so we have to invest heavily in both the hardware and the software to maximize the security around devices. So if you sort of chunk that up, $4 billion a year in R&D, primarily focused in the cell phone space on three legs: security, connectivity, and compute. And what we do in the Internet of Things group is we leverage that technology that's put into the mobile phone space into adjacent spaces. So when we go and talk about 5G going into adjacent spaces, we're not just trying to provide a connectivity solution, we're also providing to customers in that space compute and security.
Right.
But then let's, with that, let's double click on the connectivity generations. Absolutely the move from 4G to 5G, it's very exciting in the cell phone space. I think the first thing that enables is tremendous increase in capacity and a reduction in cost per bit. So a carrier can provide multimedia services to a consumer on a 5G smartphone at a lower cost per bit, and there's lots of bits involved. So that's a fundamentally great business case.
Yeah.
And I think in the consumer space, we'll see a whole load of new use cases around computer vision or rendering graphics, where the low latency link between the cloud and the device will benefit the consumer. But at some level, it's another generation. Yeah, it's the transition from 3G to 4G, 4G to 5G. So it's sort of more of the same in a very saturated compute space. What is different is when you look at the use cases for 5G out of the cell phone arena, it's really interesting. And it's not just interesting because 5G is supporting new sort of fundamental building blocks, which we can talk about. It's interesting because it's happening at a time where we're seeing productivity being driven by digitalization, by the digital twin, by getting more sort of internet-like efficiency in real world businesses as opposed to sort of internet businesses. So those two things coming together, a whole lot of new technologies enabled by 5G at the point that we're seeing industries transition very quickly, creates a very interesting space for 5G.
I think one of the things, and when we talk about 5G internally, a lot of times people ask me about 5G, and I have to remind them it's not just about the bandwidth. It's not just a faster connection. I mean, as you're mentioning, it's a higher density connection. It's a lower cost connection. It's a lower latency connection. So that's kind of a factor that I think people are still wrapping their heads around, that, once you get something that has all these kind of factors, that it's almost hard to predict, like which industries are really be disrupted by or take advantage of all of those factors around 5G, right? It's not just faster phones. That's a good place to start, but it's all these other things. And then people are, like you said, real businesses, in energy and healthcare and in manufacturing are wrapping their heads around, what can I do with this thing?
Yep. And I think it truly is, we've talked about, we think about the internet enabling a lot of new businesses. I think from a Microsoft point of view, you can see that with Azure, by pushing compute into the cloud, changing the architecture, you can enable businesses to create profound productivity gains. What 5G will enable is a much broader interface with the real world. And exactly on those three pillars, we think about the same things. We think about enhanced broadband, so gigabit level connectivity. We think about massive IoT, so we think about high data rate connectivity to 1 million devices in a square kilometer. So that's one device per square meter, so super high density. And then we think about ultra reliable, low latency communication. We're sort of used to very reliable communication because we can, over a radio channel, we can achieve that by retransmitting when packets are in error. But when you retransmit, you create you extend the latency, and that's undesirable for real-time control cases. So in 5G, there's a protocol called URLLC, Ultra Reliable Low Latency Communication. This provides a sort of a fundamental 10 to the minus 6 reliability and millisecond round trip delay. And I think the one sort of real life point that brings the ultra low latency to the one thing that brings the low latency to life is if you think about a honeybee. Yeah, so a honeybee, I think it's 5 milliseconds to flap its wing up and down, and you think in the time there's one flap of a honeybee's wing, you can send a signal, to the network, back to the edge, to the network, and back to the edge, and have some time left over just in that one flap of the honeybee's wing. It's amazing what that low latency, what it is from a practical point of view.
Right. And I know that you've been doing some work. I think you demonstrated at Hannover Messe last year working with Bosch and some of the manufacturing leaders on how to take 5G into the industrial space. So basically removing a lot of the cabling and turning a lot of manufacturing space into a much more flexible, sort of configurable space. That might be one of the really interesting use cases in the next few years for 5G in the industrial space, right?
No, I think that's true. I think, when, if you want to reduce, or you want to be able to bring new models to market quickly, you have to be able to redesign your factory quickly. Redesign your factory means that you need to be able to move them. You have flexibility about how you move the machines. Wiring is a meaningful overhead in that cost.
Right.
So absolutely, we see 5G going into factories, first of all, allowing a reorganization of compute. So if you push the compute back to the sort of the far edge, you can exploit the low latency links between the infrastructure and the machines. So the compute sort of resides more centrally, so you can get better orchestration. And that can sort of reduce the total cost of ownership. But I think an important point for deploying 5G in these scenarios is how regulatory authorities around the world are thinking about spectrum allocation. So very likely we will see the current mobile network operators deploy 5G, and there will be what should be a very attractive business case for them to reduce cost per bit to the users of cell phones. And then a second wave of being able to offer new services, not just based on that cheaper data rate, but based on the low latency and high density. The question is in the cities or in the factories or the retail stores or distribution centers, whether the mobile network operators are the best equipped to come and provide novel vertical solutions for distribution, retail, and manufacturing, or in fact whether another party is going to come in and provide those solutions on 5G. And the important point is the regulatory authorities around the world, so the US with CBRS, in the UK, in Germany, in Japan, some spectrum is being allocated for factories, warehouses, retail stores to be able to deploy 5G without the need of a current mobile network operator.
Yeah, no. So I think it could definitely provide some opportunities for disruption in that space. I think you could see companies, adding to their IoT practice, if you will, to bring more vertical market solutions that include connectivity, include 5G as part of the overall solution. So I think that game will definitely be changing over the next few years, and I think we'll see some telcos that are leaning in on that space too to maybe provide those professional services as well, if that makes sense for them.
Yeah, totally.
Yeah, no, I think it's fascinating, and I think I know we had talked recently about timing on 3GPP. I think a lot of people don't know what that is. Maybe you can explain that, but that the way of standardizing 5G in these waves to enable more and more capabilities over time, and over the next few years, the 5G standard will mature or evolve to include more and more of these capabilities as a standard, so that you can go from demo to product. Basically, we can move from the demo to actually deploying things in the next few years in this space, which I think will be interesting.
No, that's true. I mean, I think, Qualcomm played a huge role in accelerating 5G. And, I think that sort of unlocks a lot of economic value earlier. And, the first use case, as I said, is really to provide, higher capacity, higher data rates in the network. And in fact, the way that was done, the very first version of 5G, you have a 4G connection, and then it's like there's a turbocharge mode where you turn on the 5G. So it's anchored by 4G. So that's what we call 5G NSA, non-standalone. Mm-hmm. Then there's 5G standalone, so you anchor on the 5G. And then there's release 16, and release 16 is where you'll start to see this deployment of the URLLC. My expectation is we'll continue to see evolutions of the standard as the use cases, particularly in the non-cell phone space, become more clear. It's likely there will be pressure to, add more to the 5G standard, and the way that it's been designed is to have some sense of future proof built into it, so we can evolve not just to the foreseeable but the unforeseeable applications that are coming.
You've been listening to part 1 of my conversation with Jeff Torrance, VP of IoT for Qualcomm. In part 2, we'll be talking about things like low power wireless access, so stay tuned for that, and thanks for listening.